Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super. For today's session, we're going to be focusing on an Azure networking issue. This impacted customers in East-West 2. One of the characteristics about this, there was a very long tail recovery, so much so that it started on the 8th of January, but some customers would have experienced impact all the way up to the 11th of January. And we have two guest speakers here today to walk us through kind of what happened and what we're learning.
That's right. First up, I'd like to introduce Deepak Bansal, who's our Corporate Vice President and Technical Fellow from Azure Core Engineering. Deepak's going to be talking us through the networking angle here. Thank you for joining us, Deepak. And secondly, we've got Yunus Mohammed, our Corporate Vice President and Distinguished Engineer, who's going to be representing availability zones and resilience, some of our recommendations to survive incidents just like this one. So before we get into the specifics of actually the incident and what contributed to impact here, Deepak, I wonder if I can come to you. Could you first introduce us to PubSub? PubSub is a really big character in the story here, and some of the relevant components of what customers need to understand about PubSub. How does all this usually work, and how do we go about making changes to the system?
Yeah, thanks, David, for that question. So PubSub is an internal component of what we call the Azure Networking Control Plane. And Azure Networking Control Plane is a set of services that are responsible for provisioning networking for all kinds of resources, VMs, PaaS services, containers. Tim, can we bring up the slide that shows the architecture so that people have context about what I'm talking about? So the PubSub service is actually a regional service that gets deployed in each and every region of Azure and is completely isolated from other regions. What I'm showing here is the diagram, high-level architecture diagram for how the networking control plane services all work together and the role that the PubSub plays in the networking control plane for provisioning of network resources. So on the top, we have VMs and VMSs, right? These are the compute services that invoke the network control plane services, and also the PaaS workloads that I'm showing on the right side. The VMSs call a component called Network Resource Provider. This is again a regional service. And then the Network Resource Provider calls PubSub service, which itself is deployed zonally. So in a region where there are 3 zones, there'll be 3 instances of PubSub service. Each of those instances actually is a partitioned service. So what I'm showing here is, for example, a PubSub service in zone 1 has 5 partitions deployed, and each of those partitions itself is running on multiple replicas. And I'm showing here 5 replicas. One of those replicas will be primary for that partition. So each of the 5 partitions will have 5 replicas each. And the reason we partition the state is so that if any of the partition goes down, there is no impact to other partitions, as well as the 5 replicas are all standing. 4 of the 5 replicas are standing by in case the primary replica were to fail. One of the other replicas are going to pick up. So the network configuration gets delivered from the network resource provider by the PubSub service to the agents which are running on each and every host in a given zone and across the various zones within a given region. So that's the role that the PubSub service plays. Now, before I move on to the next question, one thing I want to highlight, the regional components like the network resource provider here is talking to multiple PubSub services in the different zones. So even if one of the zones were to go down, the network resource provider is able to route requests to the PubSub service in a different zone. However, on the container workload, server workload side, the Swift component that is responsible for generating the network goal state has a dependency on PubSub in zone 1, and that played a critical role in terms of causing the massive amount of impact that this outage caused, because Swift component itself didn't leverage the PubSub service in the other zones, and the Swift component in all the zones in this region had a dependency on PubSub service in zone 1, which led to the impact which was broader than that zone for our serverless services.
Super. Thank you, Deepak. I remember someone telling me that the PubSub service is like the sorting hat of Azure, which I found very helpful to kind of understand how the service works. If we were turning our attention to the outage that started on the 8th of January, one of the things as we're reading through the PIR at a high level, the bit that caught my eye was an operator didn't follow the prescribed procedure. Now, I'd love you to talk us a little bit through what this was and why this acted as such a huge trigger.
Yeah, so we have well-defined procedures within Azure for applying any changes into production, right? And any change must follow safe deployment practices, must be deployed in canary region, followed by pilot region, and then a well-defined stage map of regions through which it goes in production, right? In this particular case, the operator did deploy the change, and the change was actually a planned change, right? There may be changes that we may need to make in response to a live site, already ongoing live site, and we have to mitigate a live site, but that wasn't the case in this scenario. There was a new feature or performance improvement, more accurately, that was being flighted, and the operator deployed it in canary, and then deployed it in pilot. And after deploying it in pilot, went straight to East US2, bypassing the stage map that all changes are supposed to follow. And the other aspect that was crucial in understanding this outage was all changes are supposed to be done in an automated fashion. So that ensures that the way we make those changes are repeatable, so we get repeatable outcomes when the change rolls out through production. In this particular case, the change wasn't done in an automated fashion, but was done in a manual fashion. So the way operator made the change in Canary, so the way to apply the change is to apply it to the first replica of a partition and then wait for a given period of time for that replica to come back healthy, then apply it to the next replica, and then go on to complete all the replicas in one partition. And then once one partition is healthy, then move on to the next partition, and so forth till all the partitions in a zone are done. So the operator did it correctly in the canary environment, where they gave sufficient gaps before they moved on to the next replica and the next partition. And they followed that same procedure in pilot region as well. However, when that change was made in East US2, the operator did not wait long enough. On the contrary, the operator applied the change to all the replicas on the second partition. So what was strange about this outage was partition 1, the operator followed the right procedures, even in East US2. So the partition 1 came healthy, but when the operator moved on to partition 2, the operator didn't give enough time gap between the operations on different replicas. So all the 5 replicas of partition 2 came down, which led to what we internally call quorum loss. So as a result, the indexing data, and I'll explain the indexing data in just a second. The indexing data for partition 2 was lost, and then the operator moved to partition 3 without validating the health of partition 2, did the same thing on partition 3, and the partition 3 went down, and the operator did the same thing on partition 4, and partition 4 went down. And at this point, the operator noticed that the health of the services of the PubSub service and the previous 3 partition was not good, and the operator stopped. So there was no impact to partition 5. So that even though the operator didn't follow the right procedures, didn't have the automation in place, that points to primarily systemic issues, which let the system allow the operator to do such operation in an unsafe fashion. I can talk more about the gaps in the system. Um, uh, uh, so some of the gaps in the system that existed here was, first of all, operator had a direct access to East US2, even though we require what we call JIT, just-in-time access, for any touches to production, and that requires a second operator to approve that JIT request. In this particular case, that JIT request was approved by the second operator, which enabled the operator to be able to make this kind of a change in production directly. But the system needs to prevent that from happening. That mechanism is only meant to address live site issues, not to be permitted for these kind of changes to be applied to production. And as part of that process, we also mandate what we call R2D, or ready to deploy process, which basically asks operator a bunch of questions around the safety of the change, and in fact enforces that there must be an automation for any change, right? Lack of automation is an exception in that R2D process. However, R2D process is not enforced. Today, we relied on humans to follow the process, right? And that is a systemic gap that we have had, which in this case led the operator to be able to make this kind of a change. Um, uh, in addition, the R2D process enforces things like there must be a rollback that must be validated before a change is permitted to roll out to production. The change gets rolled out to production via automated deployment tool, a standardized deployment tool that we call AZ Deployer. There are actually two tools, AZ Deployer and EV2, that we use internally, and those tools automatically enforce the stage map, how the change gets staged across the regions. However, because this change did not follow the specified procedure, because the system let the operator not follow the specified procedure, the change didn't go through AZ Deployer or EV2 and was instead made in the regions as deemed by the operator, which led to the change getting directly applied to East US2 after the pilot region, and that caused the impact to East US2, which is one of our biggest regions.
Got it. That's a great thorough summary, Deepak, of kind of what was supposed to happen and the operator error here. I think the systemic view of like what should have happened, we'll definitely make sure we have time for our learnings and repair items, but I liked the framing of course, operators, might make mistakes, operators might not follow procedures, and I'm glad that we're acknowledging here that the system kind of lacked those appropriate safeguards. So we'll definitely touch to some of those learnings later on. But before we get to it, I wanted to ask you from a customer's perspective here, what did customer impact feel like? Now that we understand PubSub and we understand that the change that was made in error by the operator, what would customers have felt? What would they have noticed? What would they have been unable to do?
Yeah, so as I showed in the architecture diagram, PubSub is a very critical component of the overall Azure platform. And as I demonstrated, two broad set of scenarios, VMs and VMSSs, and then the serverless scenarios. So for VM and VMSs, what customers noticed was VMs that were newly created may not be able to talk to each other or to talk to existing VMs and VMSSs. And this impact was mitigated a few hours into the outage, because the way VMs, the newly created VMs, talk to existing VMs is by looking up mapping data, which translates the IP addresses, the logical IP addresses of the virtual machines to the physical IP addresses that our network infrastructure uses to route traffic between the VMs and VMSSs. So that mapping data, the VMs in AZ1 may not be able to find because the PubSub for those three partitions was down. However, early in the outage, we were able to point those agents to fetch the mapping data from the other two zones, because as I showed in the architecture diagram earlier, the network resource provider publishes the data to all three zones. So that was the first impact, which was a connectivity impact. The second impact was private link connectivity impact coming from on-prem or from compute to PaaS services. Again, that's the lookup data that took slightly longer for us to fail out because we had some gaps in how we can automatically fail out or do it easily. So that was the impact on the VM and VMSS side. Now, when we look at the serverless set of our services, a subset of our serverless services relied on this component Swift that I alluded to earlier, and the Swift component had a dependency on Zone 1, even for serverless services that were in Zone 2 and Zone 3. Because of that dependency, the serverless services subset of serverless services were impacted region-wide, where they wouldn't be able to create new functions or new containers, or those containers wouldn't be able to, the newly created containers wouldn't be able to talk to existing containers. So that was the connectivity and the serverless impact to a subset of services, which was quite severe and took a long time for us to recover, much longer than it took us to recover VM and VMSSs. And that was purely to do with the internal dependencies we had, which are meant to be zonally resilient. So Swift was meant to be zonally resilient. So this gap was purely on our side and something that we should not have had, and there was a gap in the platform that led to region-wide impact, even though we strive to ensure that all our services, which are regionally redundant PaaS services, they do not get impacted by a zonal outage. But here we violated that promise on the platform side by having a zonal outage have a region-wide impact for our PaaS services.
Deepak, you've touched on so many interesting things. I really like the way we've unpacked the operator error, and you've kind of gone into a huge amount of detail about, like, it's one sentence, but there's a lot of work that goes behind it. For me, when I understand, hey, once we understood this issue, this is clearly a class of issue that we haven't, practiced or drilled or mitigated before because of the length of the outage. The response to me was overwhelming, just to read about all the things that we had to do in order to face this kind of class of scenario that we'd never faced before. We had to build things and do things that we haven't done before. Could you walk us through how the team had to respond and the things that we did to get our services back online?
Yeah, so the first thing I'll start with is that this was a partial outage of PubSub in Zone 1. Pretty big, but it was partial in the sense that partition 1 wasn't impacted and partition 5 wasn't impacted. It was partition 2, 3, and 4 that were impacted, which made recovery complicated because the service itself was up. It just wasn't serving data, subset of the data that was in partition 2, 3, and 4. And I want to point out that we actually did not lose any customer data in this outage. What we lost was indexing data that is meant to be used by PubSub service to look up customer data, right? So when the request comes to the PubSub service, it maintains an index of where that request is supposed to be routed, and we lost that indexing data to route the request to the PubSub service. Because the outage was not complete, some of our failover mechanisms did not work automatically. Because they were still able to reach the PubSub service, the data that they were getting indicated that data did not exist, but those services agents had no way to know that it was lack of data, not in fact a planned deletion or something like that. So being a partial outage caused initial complexity in our recovery steps, where we had to determine, hey, do we take down the PubSub service in Zone 1 entirely, but then the impact gets expanded to partition 1 and partition 5 as well. The other part which really elongated this outage and caused the recovery tail to be so long was the fact that the indexing data uh, we had to rebuild as part of recovery from this outage. So we had to look up the backends and fetch the data from the backends and rebuild the indexes for those backends. And that's an exercise that we hadn't exercised in our DR drills before. Like what we had exercised is hey, if the indexing data is unavailable, what is the impact and how we bring back the indexing data. But in this case, because we had to rebuild the indexing data, we had to write tools to dump the information from the backends and then write tools to fetch the index from the backends and then load the index. There was a huge amount of data in these three partitions, right? Over 6 million objects per partition. So rebuilding that index and then uploading that index into the partition manager itself took us a while. So that's what led to long recovery time, because it needed us to exercise things that we hadn't exercised before, and that meant writing of new automation and then validating that new automation before we apply it to production.
Got it. That's great to understand. Two points you touched on that I just want to reiterate because I think they're really worth noting here is one is we didn't lose any customer data. We only lost our index of it. I think that's important to highlight here. And then secondly, I really like your view, Deepak, on saying, hey, we run drills, we drill all kinds of things. This wasn't something that we had been able to drill properly. And that's something that we have had come up in sessions like this before. Kirill Gavrilik, who runs some of our other services, says our drills are often too neat. Our drills start at 9 a.m. once our coffee is ready. And I think this is a great example of some of those other types of scenarios that we can now drill and do a better job of. So that's a great understanding of how we mitigated the issue. I wonder if we could turn now to some of those learnings and repairs that we touched on. How are we going to do better next time? How are we going to have better safeguards to prevent against operator error? And what are we doing kind of systematically to help with this class of issue and safe deployment and safe changes generally?
Yeah, so several gaps in our system that this outage highlighted. One was it was easy for an operator to get access to production, right? And even though we required manual approval, it just needed another developer in the team to give that approval. And as this outage demonstrated, that other approver didn't do the due diligence in terms of validating that the right tooling and the processes were being followed. So we have tightened access to production such that we must have a senior engineer approve any access to production. And as part of that approval process, we have tightened ensuring that the ready to deploy is in place, right, and has been approved, thoroughly reviewed and approved. So it's no longer just that another operator can approve someone's access to production. There must be an already approved R2D for that change before even a second operator is able to approve access to production, right? So we have tightened access to production at a system level so that the system doesn't let someone bypass the safety processes, the R2D process, the safe deployment practice, SDP process, right? Next, we have looked at gaps in our DR. Actually, before that, let me talk about the lack of the zone isolation that existed in this case, particularly for the Swift scenario for serverless workloads. That's a gap that we have fixed actually in the Swift component itself. The serverless services which are using Swift are in the process of deploying a change to adopt that Swift resiliency aspect. Different serverless services are in different stages of that deployment. We expect bulk of those services to be mitigated by the end of February. and then there are a couple of services which will deploy that change in March. This is the highest priority for the platform because that's an architectural gap that we had that we must not have. So wherever we had this region-wide dependency on a zonal component that is being fixed in the context of Swift, and we are conducting a thorough review of anywhere else if a serverless region-wide service or VM or VMSS has a dependency on a zonal component that would expand the impact of a zonal outage to region-wide. We are fixing any such gaps. We are conducting a thorough architectural review and identifying any such gaps. We haven't found any such gaps so far, so except for Swift, which we are prioritizing and fixing. The next was rollback and automation around recovery, right? As I mentioned earlier, we do DR drills. However, this particular failure mode wasn't exercised in the DR drill. We have built automations now for this scenario such that if such an issue were to happen, we are able to recover the indexing data within a couple hours, even lesser than that, and do not have to rely on this long process of rebuilding the data. So we are improving our recovery times such that we are able to recover from this issue or similar issues in a much faster way. Yeah, so those are, I think, the key repair items that we are taking to make sure that not only does this issue not happen anymore, but this class of issues do not happen anymore. And we are very committed to our zonal isolation. We know that our customer depends on our platform, our regional services to be protected from zonal failures, and customers should not have to worry about the resiliency of a regional services to zonal failures. So that's a promise that we violated in this case, and that's a promise that we will not violate in future by putting these architectural improvements as well as fast recovery and the procedural and the automation improvements in place.
So, super. Thank you very much, Deepak. Yunus, thank you for waiting patiently. I'd love to turn my attention to you. Deepak's mentioned a couple of times Swift, V1, V2. We learned about the pub sub service, what that does and why it plays a critical role. We didn't include Swift in the PIR, but it sounds like it's a key actor here in this. Could you talk us through what Swift does and the difference between V1 and V2 and why that was critical in this case?
Absolutely. Swift is an internal service that is critical to container networking, and services that have containers, host containers, and then provide networking for those containers. They rely on Swift. It's not like a service that's visible to our customers and that they consume it directly. It's a service that's used internally. Like Deepak covered very, very extensively in this case. What happened was Swift, which is the internal networking service, had a dependency on a single zone and was not resilient across zones in the region. And the net effect of that was when that zone was impacted because of this manual error, then the services that had dependency on Swift, regardless of what zone they were in, were impacted. So those services were impacted at a regional level and not just at the zonal level. So that was the fault that we found in this case. The clear lesson is that all of the components in the platform services, even the ones that are not visible to the customers, all have to be zonally resilient, and that is when the full promise of the zonal resilience shows up. So in this regard, Sam, I want to kind of show a little bit other side of the equation about how zonal resilience worked. Now, for all the services that are zonal resilient and did not have a dependency on Swift v1, they actually survived this failure. They were not impacted by the impact to the pub sub and to Swift in one of the zones. And that again underlies our principle that that zone resilient SKUs of the services is the way to go. By that I mean Cosmos DB, SQL DB, VMSS, or Service Bus. Whenever you use these resources, the guidance is please use the zone resilient SKUs of this, and so that if there is an impact for whatever reason, it could be power outage, it could be manual, it could be a manual error, it could be something else. Whatever reason that there is an impact within a zone, but then your resource, because it is spread across zones, is not impacted. That principle still holds, and it is further reinforced by this incident. We just found a gap, unfortunately, and we're going to go fix it. And we're going to, like Deepak said, we're going to systematically fix any other component. We haven't found any other component other than Swift v1. Even Swift v1 has gotten patched by now. I think Deepak mentioned. And Swift v2 is completely zonally resilient and does not have any of these issues. So we believe we have taken care of this, but we're going to be super diligent. But the guidance for the general guidance states that use the zone resilient SKUs of the services.
That's great. Thank you, Yunus. So good to understand why some of those internal services who thought they would be zonally resilient actually weren't, because we were taking that dependency on Swift v1. So I wanted to ask you the same kind of question, but instead of focused on our kind of internal downstream services, let's pivot now to talk about our customers and our customer workloads. That, like you said, even if they had tried to architect to support multiple zones, that there were some gaps there as we understand it. What recommendations would we give to customers to be more resilient to this kind of thing? I mean, we do have regional outages sometimes. I mean, customers shouldn't be putting all of their eggs in one basket in EastUS 2, or is this one really on us? Like, what guidance would we recommend for customers who really had this impact something that was mission critical for them?
I mean, I have to say in all truthfulness, this is mostly on us, right? And we are taking care of it. But that said, let's reiterate the customer guidance. The guidance is to use multi-AZ resource SKUs. Cosmos DB, SQL DB, VMSS, Service Bus, all of this, they all have AZ resilient SKUs, continue to use them. And those will kind of defend the workload from zone specific failures. The other guidance is for stateful resources. Take example, Cosmos DB, they're really great DR options as well. So which are an additional layer of resiliency on top of the multi-AZ resiliency. So you could have Cosmos DB, say multi-AZ resiliency in EastUS 2, and then choose a replica or a failover region, say WestUS 2, which is available and have a standby copy over there. What that gives is, like, even in case of something happening at a regional level in one of the regions, the customer can quickly recover the Cosmos DB by failing over to another region, and then have the VMs there use the Cosmos DB there. So so having the DR on top of the multi-AZ is definitely the way to go for critical production resources. As far as VMs are concerned, those can be spun up in multiple regions, or depending on how the application configuration is, even the same VMSS, say in EastUS 2, could be reading off Cosmos DB failed over Cosmos DB in another region for the time period of the outage or the incident, and then it can be failed back. Because typically, VMS is spread across multiple zones. Rarely have we seen it get impacted. So there are multiple options, but definitely for the stateful resources, having it multi-AZ and then having a failover copy is a great pattern to follow.
Got it. Good summary of our guidance there, and having that zonal resilience isn't a replacement for having real kind of resilience against a whole region going down. So well said. I know we could spend hours or days talking about our reliability guidance, and that was a great succinct summary. So thank you, Yunus. At this point in the call, I generally like to turn my attention to my co-hosts here. Sammy runs our Azure Incident Communications team, and so beyond hearing about what our services can do differently or what our service teams learn from this, we want to check in on communication. So Sammy, how did we go at keeping customers up to date?
I'll borrow a sentence from Yunus and say, I think this one's on us. And we didn't do very well. Our first communication went out about an hour and 15 minutes after impact start, it can happen when we're unclear. We ended up going broadly to our status page at around 1:28 a.m. I think as we kind of understood, it was a very rare scenario that we found. We found that the pub sub service wasn't working as expected. We did a suite of new things in order to try and rebuild, and we created playbooks on the fly, and we didn't do a good job communicating this at all. At some point in time, we had leaders who would say things like, we recommend that customers fail out of the region. And so we wrote that down for customers. And I'd like to reiterate our stance. We mentioned this in the PIR. It's not our job to tell customers what to do. Our job is to tell customers what's going on, whether it's where we are in the investigation, what we're doing about it, what the issues are, and how close we are. And if we don't have an ETA, maybe we can give an approximate ETA. And we can say it's going to be at least 5, 6, 7, 8, 9 hours. The idea is to arm customers with enough information that they can make business decisions, not to advise customers how to invoke their BCDR strategy. I think at some point in time, as customers read through the PIR, they can read all the things that we were doing. We were rebuilding, we were getting the replicas up and running. And at the very last kind of hurdle, and this is when we started providing ETAs, we saw that we had the wrong source file. And so it's like we had to go all the way back to square one. I think at that point in time, we withdrew from calling out ETAs. One of the things I will say to our customers is that we ask for permission to be wrong when it comes to providing ETAs. We can be right and say nothing, or we can be wrong and hazard a guess with what we know. And so I ask our customers for permission to be wrong, but be as transparent as we can be. One of the other things is the fog of war. I'm sure most people understand the fog of war. It's hard to get information out. An area where I think, again, we didn't do a great job was we inherited the fog of war as time went on, and we could have done a better job of clearing out kind of all the stuff and tell our customers what was going on. Generally speaking, if this issue lasted 1, 2, or 3, 4 hours, you would almost forgive the kind of hazy comms that wasn't very clear. But because this went on for multiple days, we had ample opportunity to provide clarity to our customers on what was going on. We know what the pub sub service does, and we miss that opportunity to do so as well. In addition, we found that I do want to give a special call out to Databricks on Azure. It's Databricks on Azure, and so we didn't do a great job with keeping our Databricks customers updated as we did with some of the other services as well. So I think overall, this has been a very painful one for our customers. It was very painful for the communications team as well.
Got it. Yeah, especially for such a long outage or such a long-running incident like this. What a great opportunity for us to regroup internally, figure out what the story is, and help customers to understand where we're at and what we're doing about it. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alert set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.